Hello, algebra students. Mr. Lawrence here, and this is your test review. So let's get down to it. We're writing some functions here. I've got 4 problems. You can only see 2 of them. Not showing the other ones yet. Not going to do it. Going to make my table x and f of x. Do you have to do all this work? Not necessarily. You got to understand that x is your input and f of x is your output, and that x is inside the function. But some of you can see these patterns more easily than others, and that's fine. So 6, 21, 44, 75, 144. All right, so going to look for my first differences. Looks like a plus 15, and then a plus 23, yes, and a plus 31, and then a plus at 39, I think that is. Man, that's not supposed to say 144. It's supposed to say 114. Sorry about that. This is the 3rd time I'm making this video because I keep making silly mistakes. Oh dear. There we go. So that's supposed to be good. All right, I'm done erasing. Now I scribble and I write 114. I am smarter than you, smart board. Anyway, 144. Okay, quit laughing at me. All right, so yeah, we're going to scribble again. Okay, 114. Sorry about that. So that is plus 39. Okay, I am not sure what is going on. My computer probably needs to be restarted. All right, so we got plus 8 and plus 8 and plus 8 on the second difference. So it's quadratic, but we should know that it's going to be 4n squared for our pattern, right? Not n squared. It's going to be a 4n squared. So now I do my comparison line. I put 1, 2, 3, 4, 5 in for n. So I square 5 and get 25 times 4 is 100. And then 4 squared is 16. That'll be 64. And then I square 3 and get 9, and I'm going to get 36. And then 2 squared is 4, 16. And then 1 squared, 4. Okay, so now I'm going to compare up. And I'm going to get rid of these numbers only because they're in my way. Normally you won't do that. And so how do I turn these green numbers into the black numbers? Well, that's plus 2. That's plus 5. That's plus 8. That's plus 11. And that's plus 14, right? Well, if you don't see it, you can go ahead and make another table. I think Sean's group was doing that. Sean and Caitlin, I think it was Nick Zagrafos. All right, so, oh dear. I have no idea what's going on with this thing. All right, so I'm going to take these blue numbers here and I'm going to put them in a new table. I'm going to go 2, 5, 8, 11, and 14. And I'm going to do the same thing. And then I'm going to combine my 2 answers, my quadratic part of my answer, with the leftover part. The leftover part should be what? Yeah, linear, right. 1, 2, 3, 4, 5. And then n. And so I go finding my first differences. Looks like it's plus 3. And so this is going to be a 3n. And I'm going to get 3, 6, 9, 12, 15. And it looks like I'm going to subtract 1 every time. So I'm going to have 3n minus 1. So my function is going to be f of x. And I need to include the 4x squared. And then I need to add on the 3n minus 1, or the 3x minus 1 in this case. And there's your function. And now I could go and find any term in the sequence I wanted. All right? Okay, here comes b. So we're going to have x, and we're going to have f of x. And we've got 1, 2, 3, 4, 5. All right. And then we've got 4, 22, 120, 618. And 3,116. I've been making lots of silly mistakes today. I guess I'm tired. I'm not really sure. I don't feel that tired, but so I'm going to go ahead and use my calculator and just double check my math here. but that's plus 18. I don't need it for there. That's going to be plus 98, I believe, right? Okay, 618 minus 20. 498. I'm going to double check. 618 minus 120. Yep, 498. That's cool. All right, and then 3,116 minus 618, 2,498. So I go down to my second differences, and I've got plus 80, and then plus 400, and then plus, yeah, it was 400, 2,000. Okay. So how do I change 80 to 400? Well, I could add, but what if I multiply by 5? If I multiply that by 5, looks like this is going to be exponential. It's going to be something like 5 to the power of n. So I do my comparison line, and I'm going to go ahead and erase these. I don't want you to erase them on your work. Don't erase them. If you need to rewrite it in a neater way, that's fine. But 5 to the first is 5, and then 25, and then 125, 625, and 3,125. And it looks like I'm going to subtract 1, and then subtract 3, subtract 5, subtract 7, and subtract 9. So this looks like I need to make another table again. So I'm going to go ahead and make a table out of those green ones. And I got what? At 1, I got -1. And at 2, I've got -3. And at 3, I've got -5. And then at 4, I've got -7. And at 5, I've got -9. Okay? And so there's x and f of x. And let's see here. I'm going to go looking for the nth term. Now, some of you will recognize this pattern already, but if you don't, that's okay. And it looks like the first differences are all the same. So they're going to be a -2n, right? And if I do a -2n, I better change colors there, sorry. Let's go red, -2n. So 1 times -2, -2, -4, -6, -8, -10. Looks like I'm going to add 1 each time to turn the red ones into the green ones. So it's going to be -2n plus 1. So my function is f of x equals 5 to the power of x minus 2x plus 1. And there you go. And I got to let you in on something. I don't know that I've done anything this complicated with my algebra students in a long time. That is a tribute to you, ladies and gentlemen. I think you can handle it. So feel good about that. All right, got 2 more here. And so let's see, get my table going. We've got x and f of x. And then 1, 2, 3, 4, 5. And then we'll get 0, 4, 20, 48, 98. All right, and we'll do our first differences. Plus 4, plus 15, plus 28, plus 50. Okay, second differences. So I got a plus 11, and then a plus 13, and then a plus 22, right? Oh, this is bothering me. Plus 2, plus 9. I don't see a pattern here. There must be a mistake. Oh, there it is. I see it. Hold on a sec. Let's see if I can fix it. Okay, this would be plus 16, right? And this would be still 28. And this will be still plus 50. Oh, that 50 is a mess. I'll bet you, yeah, 50. I only want it to be 40. That's supposed to be an 88 there. Sorry about that, ladies and gentlemen. Said I'm kind of tired. I'm not trusting myself. We're going to change this to 88. On the good note, I was able to erase without erasing everything in the table. All right, 88. Yeah, this is better. Okay, so there we go. That's going to be a plus 40. And when I come down to second differences, I got plus 12, and that's plus 12, and that's plus 12. So this must be a 6n squared, and I guess I should do that in a different color. So this is going to be a 6n squared. So 1 squared times 6, 2 squared times 6, 3 squared times 6, 4 squared, 16 times 6, 96 I believe, yeah, 96. And 5 squared times 6 will be 150. Okay, so it looks like I'm going to have to make another table on this one, but let's see what happens. That's what, minus 6, minus 20, minus 34. Okay. 40. No, it'd be 50. It should be 48. Yeah, that looks right. Okay, minus 48. And 90 would be 60. Be, wait a minute. 150 minus 88. Yeah, I'm screwing up here. Okay, 62. That looks better, minus 62. So now I'm going to make a table out of those residuals. So I know it's going to be something 6n squared, but I'm going to take the negative 6, the negative 20, the negative 34, the negative 48, and the negative 62, and I'm going to two, 3, 4, 5. There's n, there's x, and there's f of x. All right, so it looks like I gotta subtract 14, subtract 14, subtract 14. So it looks like it's going to be minus 14n. And that will be negative 14, negative 28, negative 42. And it looks like I'll have to add 8 each time. So it's going to be negative 14n plus 8. So my function is f of x equals 6n squared, well, x squared, excuse me, x squared minus 14x plus 8. And there you go. All right. I know you'll be having an easier time. I'm just mentally, I'm kind of dead. It's been a long day. All right. Okay. One more of these, and then we'll move on. So I've got x, and I've got f of x. 1, 2, 3, 4, 5, and n. And then I've got 5, and 40, and 95, and 150, and 215. And so I go looking for the first differences yet again. And so when I do that, I get plus 35, plus, there's another mistake. All right, there's another mistake. 35, this should be 85. So let's see here. I'm just making mistakes all over the place. All right, so 85. Okay, that should be 140. Okay. And that should be 205. Yeah, that should be 205. Okay, I think we're good to go now. Didn't have to scrap the whole problem. So let me change these numbers here. Get them right, Mr. Lawrence. Take your time. It's okay. And let's see here. What do we say? We're going to 85 and 140. And then 205. All right, so this is plus 45. I believe this is plus 55, and this will be plus 65. And that means the second differences are all plus 10, which means this is going to be a 5n squared, something like 5n squared. So I'm going to square 1 and multiply by 5. I'm going to square 2 and get 4 times 5 is 20. 9 times 5 is 45. And 16 times 5 16 times 5 should be 80, right? Ooh, these are off by a lot. All right, but they're all plus 10, right? 35, 45, 55, yeah, 65, so there's no mistake there. Okay, and then 5 squared would be 125. These are off by quite a bit. I'm surprised by that, but let's see what happens. It doesn't look like it's going to be another linear pattern. It was 10, so 5 squared. Yeah, I didn't make a mistake there. All right, so that's plus 0. That's plus 20. That's plus 40. That's plus 60. That's plus 80. Huh. All right, so let's make another table. 0, 20, 40, 60, 80. Guess it's okay, it just was really surprising me. All right, and then 1. What Hukovada just happened? Okay, so it's going to be 1, and 2, and 3, and 4, and 5. And it looks like they're all plus 20. Right? So that means it's going to be 20n. But 20 times 1 is 20, not 0. 20 times 2 is 40, not 20. 60, not 40. 80. Looks like I have to subtract 20 from it. So this function is going to be f of x equals the 5x squared from there. Then we're going to have the plus 20x from here, but then we're going to have to subtract 20 every time minus 20. There we go. There is our function. All right, I'm glad to be done with that section, only because I keep making so many silly mistakes. Hopefully a new section and I'll have a fresh look on things. All right, we're going to talk about arithmetic and geometric sequences. Remember our equations. Arithmetic sequence, a sub n equals a sub 1 plus d times 20n minus 1. N is just the number we're on. D is the common difference. A sub 1 is the first term, and a sub n is the number we're going to. So here's a sequence, 7, 13, 19, 25, 32. And I have to find a of 38. Well, the first thing I want to do is find my first differences. Looks like it's plus 6 every time. This would make a linear function. Linear functions fall into arithmetic sequences. All I'm going to do is plug my numbers in. A sub 38 is going to equal a sub 1, which is 7 in this case, plus d, which is 6 from the plus 6, times n minus 1. What's n? Well, it's 38. A sub n, 38. So I'm going to get 38 minus 1, which is 37. So I'm going to do that on my calculator. A sub 38 is going to equal 7 plus 6 times 37, which is 229. 229. Now, I don't know if it dawned on you, but you could find the first term of an arithmetic sequence. I want you to find a sub 1 if a sub 12 equals 33 with a constant difference of 2. Remember, our formula is a sub n equals a sub 1 plus d, the common difference, times n minus 1. Well, let's see, a sub 1, we don't know. That's going to stay the variable. D we know is 2. Do we know n? We sure do. It's 12. It's right there. 12 minus 1, and a sub n is 33. Now I'm just going to solve this equation for a sub 1. So 33 is going to equal a sub 1 plus, this would be 11. That'll be 22, 2 times 11. And then I'm going to subtract 22 from both sides, and a sub 1 is going to end up equaling 11. And there you go. The first term of the sequence is 11. All right, we can do similar things with geometric sequences. Remember, that's when they're going to be like exponential. We've got the same equation. There we go. We've got 36, 18, 9, 9 halves, 9 fourths. Well, it's dividing by 2 every time, right? Or you could say it's multiplying by a half. All right, so we're going to multiply everything by half. So a sub 10, we're just going to plug in the formula. A sub 1 is 36. R is 1/2, the common ratio, times a half, and to the power of 10 minus 1. Where did I get the 10 from? Right there. So this is the same as 36 times 1/2 to the 9th power, which is 36 times 1 over, is that 512? Let me see, 2 to the 9th power. Yeah, 1 over 512. All right, well, I simplify that. 36, let's see, I think 4 is going into both of them. So is 9 going into both? Nope, 9's not going into both. So I'm going to divide by 4, and I'm going to get 9, and that's kind of cool. Notice my fractions are all 9 over something, so that makes a lot of sense. And if I divide 512 by 4, I get 128. So this is 9 over 128. That's the 10th term in that sequence. All right? Okay. Here's a sub 1 if a sub 12 equals 7/28 with a constant ratio of 1/2. So a sub 12 equals a sub 1 times the constant ratio to the power of n minus 1. I'll fill in what I know. A sub 12 is 7 over 128. A sub 1 I don't know. Constant ratio is 1/2. And it's to the power of 11, I believe. Right? 11? Yeah, because n is 12. Okay, so I've got 7/28, 7 over 128, sorry, equals a sub 1 times 1 over 2048. How to get that? 2 to the 11th power. Okay, it's in the denominator. Now, by the way, if you want, it might be easier to think about this as a to the first times 1 over 2 to the 11th. And I know that's a power of 2, that 128 there. And so I'm just going to figure out what power of 2 it is. 2, 4, 8, 16. That's 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th. So that's 2 to the 7th. And see why I'm going to do this. Now, to get rid of this fraction, I'm going to multiply by 2 to the 11th power. I'm going to multiply by 2 to the 11th power. Well, do you remember that, like, x to the 10th over x to the 4th would equal x to the 6th, right? Well, here I have 7 times 2 to the 11th over 2 to the 7th, or 1 times 2 to the 7th. I can simplify this. And that's going to end up being 7 times 2 to the 4th. It'll all be over 1, so it's just 7 times 2 to the 4th, not 24. And 2 to the 4th was 16. So this problem is 7 times 16 in disguise. Put 7 down there. We're going to get 2, 4, 112. So a sub 1 is going to equal 112. And there you go. All right. Rads. Okay, we're going to multiply rads. We're going to do 4 times 7, get 28. Big mistake coming up. A lot of people write down rad 5. Absolutely not. Rad 5 times rad 5 is 5. So my problem is 28 times 5. 28 times 5. 0, carry the 4. 10, 140. My answer is 140. Okay, over here, I got 6 times 5. Going to get 30. Rad, I'm not going to write 150 under there. I'm going to write 3 times 5. And for the 10, I'm going to write 5 times 2. The 5s are going to come out. I'm going to get 150. And inside, I'm going to get rad 6. This is child's play. This is too easy. All right. I want to find the area and perimeter of this. Perimeter, I'm just going to add my like terms. The only problem is, see this rad 8? I'm going to simplify them. 3 rad 8. Well, let's see, that's 3 times 4 times 2, which is the same as 3 times 2 times 2 times 2, which means that 2's go out front, which is 6 rad 2. I'm going to cross that out and use 6 rad 2. Now I'll do the perimeter. You may want to write them on the other side. 6 plus 6 rad 2 and 4 plus rad 2. And I'm just going to count out my whole numbers, my rational numbers, which is 4 and 6 and 4 and 6. So I'm up to 20 for my rational numbers. So the perimeter is going to be 20. Okay, now my irrational numbers. I've got a 6 rad 2 and a rad 2, so I'm up to 7 rad 2. And there's 7 more rad 2s over there. So now I've got 14 rad 2. So plus 14 rad 2. And that'll be in inches. All right. Now to do the area, it's a double distribution problem. I'm going to take 4 plus rad 2 as a quantity times the quantity of 6 plus 6 rad 2. Remember, I simplified that. I'm using the simplified form. And I'm going to double distribute 4 times 6 plus 6 rad 2 plus rad 2 times 6 plus 6 rad 2. All right, so I'm going to double distribute, and I'm going to get 24. I'm going to get a 24 rad 2, and then I'm going to get a 6 rad 2, and then I'm going to get a 2, rad 2 times rad 2. And so combining my like terms, I'm going to get a 26, and I'm going to get a 30 rad 2, and that's going to be inches squared. And there you go. All right, I'm going to call the video there. Mr. Lawrence signing off. Have a good night, everybody.